Welcome to This Explainer. Today, we're basically putting on our code breaker hats to tackle what looks like a totally daunting 6-page Grade 9 math paper. But hey, instead of staring at this massive stack of questions and panicking, we're going to decode the hidden logic behind this test, step by step. It's like a giant puzzle, and we've got the cheat codes. So to make this easy, we're sorting the whole paper into 4 conquerable zones. We've got numbers and arithmetic, mastering algebra, geometry and measurements, and finally, graphs and real-world math. Let's get right into it.
Starting off with Zone 1, numbers and arithmetic.
Now, what's really fascinating here is how the exam actively tests your mental flexibility. It isn't just throwing basic addition and subtraction at you. No, it challenges you to literally jump your brain between our everyday base 10 decimal system, dealing with normal numbers like 1199, and the computer language base 2 binary system, where numbers look entirely different like 1011 and 1101. The key to acing these? Just realizing you're simply translating values between 2 different languages. That's all it is. And take a look at question 4. I love this one, because it specifically tests if you understand the exact logical sequence required to actually operate a calculator for a percentage problem. It totally proves that understanding the process and the tool itself is just as absolutely crucial as knowing the final answer. Moving down the paper to question 10, we hit some larger decimals, like 202.2. And this brings us to a super important formatting tool in math, scientific notation. Basically, the exam wants to see if you can take a clunky, awkward number and package it into that neat, standardized format used by scientists and engineers all over the world. But here's the thing, scientific notation is really just a simple 3-step dance. Step 1, you just move the decimal point so it sits right after the first non-zero digit. So that gives us 2.022. Step 2, you simply count the jumps you made to get there. In this case, we jumped 2 spots to the left. And step 3, write those jumps as a power of 10. Boom, you've got 2.022 times 10 to the power of 2. It takes a seemingly complex conversion and turns it into a quick mechanical routine. Easy, right?
All right, moving right along to Zone 2, mastering algebra.
Now, looking closely at Part 2, Question 5C, you might actually feel a sudden spike of anxiety seeing 2 variables all tangled up together. We've got 2x plus y equals 14, stacked right on top of 4x plus y equals 16. Let's be real, simultaneous equations are literally designed to look intimidating. I mean, these questions always feel totally impossible at first glance, don't they? You have 2 unknowns and only one brain. So how on earth do we solve for both x and y when they're locked together like this? Well, there is a very simple secret key. And that secret is elimination. By simply stacking the equations and subtracting the top one right from the bottom one, the y completely vanishes. 1 minus 1 is 0. And just like that, you've turned a complex 2-variable nightmare into a basic 1-step equation to find x. Once you have x, you just plug it back in to find y. It is incredibly satisfying once you see the trick. Algebra also tests your pure pattern recognition. Look at question 7, 4x squared minus 25. To an untrained eye, sure, it's just a random mix of numbers and letters. But if you spot the hidden difference of 2 squares pattern, if you recognize that 4x squared is just 2x squared and 25 is 5 squared, well, that is your instant ticket to full marks. It's like finding a cheat code for the test. Okay, we are officially halfway through. Let's jump into Zone 3, geometry and measurements. So geometry questions absolutely love to overwhelm your visual processing. In Part 2, Question 4V, the paper throws this seemingly chaotic web of intersecting lines and triangles at you, and it expects you to find missing angles hidden within the mess. When faced with a diagram like this, your first instinct is probably to panic. I get it. How do we find angles x and y when there is just so much going on? The real trick here is to completely block out the noise. We just need to isolate the shapes and apply 2 golden rules of geometry. First up, zoom in on that x intersection right in the middle. We use our first rule, vertically opposite angles are twins. That instantly gives you the value of x. Then you zoom out, look at the triangle on the right, and apply Rule 2. The interior angles of any triangle always add up to exactly 180 degrees. Since you now know 2 of the angles, finding y is just basic subtraction, no panic required. But remember, geometry isn't just about flat lines on a page. In question 1, the exam brings things right into the 3D world with a drawing of a cuboid water tank.
And here, we are asked to measure the actual physical space inside it. By breaking this down methodically into 3 steps, you transform a simple 2D drawing into a concrete mathematical volume. First, you identify the length, width, and height. Then, multiply them together to get cubic centimeters. And finally, the exam asks you to take it one step further by converting that physical volume into real liquid capacity, like milliliters or liters. You see? We're connecting abstract math to the actual physical world.
And that brings us to our final stretch, Zone 4, Graphs and Real-World Math.
First up in this zone, we have graphs. And graphs are really just visual stories of algebra. In question 3, the exam asks you to complete a coordinate table for the straight line equation y equals 2x minus 1. You're given some x values, and you have to figure out the missing y values.
This actually brilliantly illustrates the hidden rhythm of linear equations. Look at the calculated y values as x increases by 1 each time. For every single step you take on the x-axis, the y value jumps by exactly 2. Finding this simple pattern gives you the absolute foolproof blueprint to plot your coordinates and draw a perfectly straight line on your graph paper.
But the ultimate test of your math skills comes in the final section, specifically question 7. This is where we deal with actual real-life survival skills. We are talking about calculating store discounts, converting foreign salaries, and figuring out business commissions. Take the vehicle commission question, for example. The math reveals that a seemingly tiny 3% commission on a vehicle sale equals a massive 60,000 rupees. When you actually run those numbers and calculate that correctly, the true, tangible power of percentages becomes very, very real. It's no longer just a number on a page, guys. It is literally somebody's paycheck.
And look at the currency conversion question. Whether you are translating a $1,200 overseas monthly salary into local currency by multiplying it by the exchange rate, or you're figuring out if a 20% profit margin makes a business viable, this step-by-step math is the exact stuff that will actually pay your bills, manage your budget, and maybe even guide your career one day. And just like that, you've successfully cracked the code of this entire exam paper. By breaking it down logically, you've proven that absolutely no problem is too complex when you have the right strategy. So, if you can confidently decode this daunting 6-page exam paper today, what real-world complex problems are you going to solve tomorrow? Keep practicing those skills, and I'll see you in our next explainer.